Okay, so this is the paper, and it is for exam 2022, paper 2. Look at the code 9702 and 22. So first, this is the data: G value, C value, speed of light, the charge of electron, and the mass of the proton or the mass of the neutron inside the nucleus, and then the mass of the proton outside. This is the mass of the electron. This is Avogadro's constant, molar gas constant, and this is Boltzmann constant, gravitational constant, permittivity of the medium, free space, and this is 1/4 pi epsilon naught together, Planck constant, and this is the new constant, Stefan Boltzmann constant. Now look at the formula. Only these formulas will be given, rest you have to remember. First two equations of motion, pressure rho gh, then thrust rho g into volume, and this is Doppler effect, frequency, and then current, series resistors combination, and then in parallel. Okay, now come to the question. Question number 1 is, the speed v of the transverse wave on the uniform string is given by the expression v is equal to under root TL over m, where T is the tension in the string and L is the length and m is the mass. An experiment is performed to determine the speed v of the wave. The measurements are shown in the figure. Tension 1.8 Newton, uncertainty plus minus 5, length 126 centimeter, and this is plus minus 1. Mass is 5.1 gram, plus minus 2. The question is calculate the speed v. So by using the equation, v is equal to under root TL over m. T is 1.8. The length in meter is 1.26, and the mass in kilogram 5.1 into 10 power minus 3, and under root whole power is 1/2. After calculation, the answer is coming 21 meter per second. So this is answer. So the minimum significant figures used, 2 significant, 2 significant. So we have to write answer only in 2 significant, not in 3 significant, because different significant figures are used. So answer must be in the least used significant figure. Next is use the answer in 1. Calculate the absolute uncertainty in the value of V. So the first, we calculate the percentage uncertainty. Look at this. The formula is under root TL over m, and under root mean 1/2. So the 1/2 percentage of T, percentage of L, plus percentage of m. So 1/2 T percentage is 5, plus length is 1, plus mass is 2. So this is coming 1/2 multiplied by 8. This is 4%. It means the uncertainty, the error in this answer is 4%. So the uncertainty in V means delta V is equal to 4% of 21. So 4 divided by 100 multiplied by 21. So you will get answer is approximately 0.8 or 0.81. So this is the answer for this absolute uncertainty. Now move to the next question. Define acceleration. So simple one. we have to write rate of change of velocity is called acceleration. And the next is a ball is kicked from the horizontal ground towards the vertical wall as shown in the figure 2.1. This is projectile motion. The horizontal distance between the initial position of the ball and the base of the wall is 24 meters, I mean this horizontal distance. But this is not the maximum range. The ball is kicked with the initial velocity v at the angle of 28 to the horizontal. The ball hits the top of the wall after 1.5 seconds. Air resistance negligible. Calculate the initial horizontal component of the velocity. So look, Vx is required. And Vx, the horizontal velocity, horizontal component, is responsible for the horizontal distance. So Vx is equal to horizontal distance divided by time taken to cover it. So the horizontal distance covered is 24 and the time taken is 1.5. Then the answer is approximately 16 meters per second. Next, show that the initial vertical component Vy of the velocity of the ball is 8.5 meters per second. Look, vertical component of the velocity divided by horizontal component of the velocity, the formula is tan theta. So we can write Vy is equal to Vx tan theta. Vx is 16 and the tan, look at the angle, it is 28 degrees. So 16 times tan 28 is equal to this 8.5 meters per second. Next is calculate the time taken for the ball to reach the maximum height above the ground. Maximum height formula is equal to V sine theta whole square over 2g, and the V sine theta is 8.5, its square divided by 2 and then divided by 10, 9.81, value in AS 9.81, and after calculation the time is coming 0.87. This height is coming. So here we have to calculate the time, not the height. So we will use the time formula, and the time formula is simple. T is equal to V sine theta over G. So it is 8.5 divided by 9.81, and the answer is coming 0.87. And the next, number 4, the ball is kicked at time 0. Assume that the vertical component Vy of the velocity of the ball is positive in the upward direction. On the figure, sketch the variation with time t of the Vy of the time. Okay, so we have to draw the Vy. Look, the initial, the vertical component is 8.5. So this is 6, this is 7, this is 8, and this is 8.5 initial when it is thrown, vertical component. And after 0.87, it reaches to the top because the time taken to reach the maximum height. And here, the vertical component of the velocity at this point, it becomes 0. So 0.87 times. So this is 1, 2, 3, 4, 5. This is 0.9 and 0.87. So 0.82, 0.84, and 0.6, so 0.88. So this is the point. So with the help of the scale, you will join these 2 points, and this is the component Vy graph. Straight line, but use the scale. Next, calculate the maximum height above the ground of the ball. So here we have to apply this formula. V sine theta whole square over 2g. So V sine theta is calculated 8.5. So 8.5 square divided by 2 divided by 9.81. And then after calculation, the answer is coming 8.5 square divided by 2 divided by this is approximately 3.7 meter. And then the question is the maximum gravitational potential energy of the ball above the ground is 22. Calculate the mass of the ball. Simple part, gravitational potential energy is equal to mgh. So gravitational potential energy is 22. Mass is required. G value is 9.81. And the maximum height gain is 3.7. So mass is equal to 22 divided by 9.81 and divided by 37. The answer will be 0.61 kilogram. The D part is a ball of the greater mass is kicked with the same velocity as the ball in B. Air resistance is still negligible. State and explain the effect any of the increased mass of the time taken by the ball to reach the maximum height. No effect, because in the absence of the air, the acceleration remains 9.81. So no effect. So state and explain. So first we have to state no effect. And the reason is G is independent of mass. It does not depend on the mass of the object. So no effect. Now move to the question number 3. The question is define force. Only the definition for the AS is rate of change of momentum is called. Next state, the work done. So what is meant by the work done? When force is applied and distance is covered in the direction force, then work said to be done. So, 1 mark. So when the question is what is meant by the work done and the marks 1, then you can write also the definition instead of the meaning. But for the 2 marks, you have to write this answer by all means. A block of the mass 0.4 kilograms slides a straight line with a constant speed of 0.3 along the horizontal surface. Assuming that there is no resistive force opposing the motion of the block hits a spring and decelerates. The speed of the block becomes to 0 when the component of the spring is, compression of the spring is 8 centimeter. Calculate the initial kinetic energy. Formula 1/2 mv square 1/2 The mass is given here 0.40 and the speed is given 0.30 whole square, and after calculation the answer is coming 1.8 into 10 power minus 2. You have to write the answer in two significant ways. Now the next, the variation of the compression X of the spring with the force F applied to the spring is shown in the figure. Assuming that the elastic potential energy of the spring when it is compression is 8 centimeter is equal to the kinetic energy of the block, use the answer to calculate the maximum force F max exerted on the spring by the block. So in this part, energy, kinetic energy becomes elastic potential energy. And the kinetic energy we have calculated is 1.8 into 10 power minus 2. And the elastic potential energy is the area under the graph. So 1 by 2 Fe. So 1.8, 10 power minus 2, 1 by 2, F required. And the compression is given 8. So 8 into 10 power minus 2 for the meters, then the F will be equal to 1.8 multiplied by 10 power minus 2 multiplied by 2 divided by 8 into 10 power minus 2, and after simplification the answer is 0.45 Newton. So this 10 power minus 2 cancelled, 1.8 multiplied by 2 divided by this. And the next, calculate the maximum deceleration of the block. Now, the force and acceleration are related by the formula F is equal to ma, then A is equal to F divided by m. This force is equal to 0.45 and the mass of the object is 0.40. So 45 divided by 40, the answer is 1.1. Next part is state and explain whether the block is in equilibrium before it hits the spring. Look, before hitting the spring, it was moving with the constant velocity, no acceleration, so equilibrium. So due to constant velocity, acceleration was 0, thus it was in equilibrium, no resultant force. When speed becomes 0 due to deceleration, there is retarding force, thus no equilibrium. So here equilibrium because the speed is constant, acceleration is 0. And the second case, when its speed becomes 0, mean it was retarding. It was coming to rest. So there is a negative acceleration, resultant force is there, so it's not equilibrium. Next is the block is now replaced by another block of the same mass. Frictional forces affect the motion of the block so that it has speed of 0.25. When it makes contact with the spring, a short time later, the block has a speed of 0.15 meter per second. As it loses contact with the spring and moves back along the original path, calculate the magnitude of the change in momentum. Look, this velocity in one direction, this velocity in other direction. If this is positive velocity, this will be the negative velocity. And the change of momentum. So the change of the momentum required, final momentum minus initial momentum. So m times e minus u. And m is 0.4. final velocity is minus 0.15 and the initial velocity is 0.25. So the final answer is coming 0.4 multiply, add these two. So it is 0.40 because these two velocities are added due to the same sign. So the multiple of 0.4 and 0.4, it is 0.16 Newton second. Now move to the next question, which is related to the wave and superposition. The question is, by reference to the direction of the transfer of energy, state what is meant by the transverse wave. So a wave in which direction of vibration of particle is perpendicular to the direction of transfer of energy. State the principle of the superposition. The principle of superposition is when two waves meet at a point, displacement of resultant wave is the algebraic sum of displacements of two individual waves. And the next, the circular water waves are produced by vibrating dipper at point P and Q as shown. So these are the two sources of the wave. They are producing wave and the wave are traveling in this direction. They are meeting at the point R. Now, the wave from the P alone has the same amplitude at R and the wave as the wave moved from Q alone. Distance PR is 44 and the distance QR is 29. The dipper vibrate in the phase with a period of 1.5 seconds to produce a wave of the speed 4 centimeter per second. Calculate the wavelength. So the formula V is equal to F lambda. 1.5 is the period, speed is this. So the formula is V is equal to F lambda. So the lambda will be equal to V divided by F. V is 4. And the time period, mean 1 over time period, frequency is equal to 1 over time period. So 1 divided by frequency 1.5. So it is 4 times 1.5. So answer is 6, means 6.0 centimeter. Because the frequency is 1 over time period, either calculate first frequency or write frequency 1 over time period here. Next, calculate the path difference at R of the wave from P to Q. Give your answer in terms of the wavelength. So first of all, we will calculate the difference of 44 and 29, and then we will convert it into lambda. So 44 minus 29, and we have to divide it by the wavelength, and this will be the path difference. So first you have to take the difference of the distances, then you have to convert it into the wavelength, because one wavelength is 6. The answer is coming 2.5 lambda, already written here. Describe the motion, if any, of the water particles at the point R. Explain your working. Look, the path difference is 2.5 lambda. So due to n plus 1 by 2 lambda, there will be destructive interference. And due to same amplitude, the crest and the trough will cancel each other. So no motion. The particle is at rest because this is destructive interference and the same amplitude is mentioned. So the crest is cancelling the trough. So the resultant is 0. Now move to the next. A beam of the vertically polarized monochromatic means single color light is incident on the polarizing filter as shown in the figure. The transmission axis of the filter is initially vertical and transmitted light beam has the same intensity as the incident light beam. The filter may be rotated about the direction of the light beam to change the angle transmission axis to the vertical. State one angle of the transmission axis to the vertical. That result is no transmitted beam. Look, if the beam is traveling in this direction and the filter is placed at the angle of 90 degree to it, so it will block all the light. So we will write this 90 degree. The filter is now positioned with its transmission axis at the angle theta to the vertical. This is the vertically polarized incident light, and here is the polarized. So its angle is theta, transmitted light beam. The question is intensity of the transmission light divided by intensity of the incident light is equal to 0.75. We have to show this. So look, the amplitude here, calculate the angle theta. So the question is calculate the angle theta. Now this is 0.75 mean we can write amplitude cos theta divided by amplitude A naught whole square is equal to 0.75 because the new amplitude is equal to A naught cos theta whole square. This is a formula for the new amplitude. So the new amplitude is A naught cos theta divided by actual A naught incident, it's 0.5. So A naught cancelled. It means cos square theta is equal to 0.75. So cos theta is equal to 0.75 under root. And then theta is equal to cos inverse 0.75 under root. So it's coming approximately 30 degrees. So this is polarization. So here the angle is 30 degrees. And the next, the ratio amplitude of the transmitted light divided by amplitude of incident light. Look, intensity is directly proportional to amplitude square. So we can write here 0. Look at this. Intensity ratio is equal to 0.75. So we can write here intensity under root is directly proportional to amplitude. So intensity 1 over intensity 2 under root. And this ratio is given 0.75 and under root mean 0.1 by 2. So the answer is coming 0.87. Intensity, original scores I naught, and then transmitted is IT. So IT over I naught ratio is already given 0.75. We have to just take the under root because for the amplitude its amplitude is directly proportional to intensity under root. Next, question number 6 is, three resistors of the resistance R1, R2, R3 are connected. The current in the resistor are I1, I2, and I3. The total current in the combination resistor is I. The potential difference across the combination is V. Show that the total resistance R of the combination is given by, look, at junction, this one, sum of the current entering the junction is equal to sum of the currents leaving the junction. So we can write I1, I2, I3, Kirchhoff first law. And I is equal to V by R. In parallel, voltage remains same. So this will be V over R1, V over R2, V over R3. Now take V common. When V is taken common, 1 over R1, 1 over R2, 1 over R3. So we cancelled. Hence, it's shown that 1 over R is equal to 1 over R1, 1 over R2, and 1 over R3. Now move to the next question, this B part. The question is, a battery of the EMF 6 volt and internal resistance R is connected to an external resistor of the resistance 12 ohm and a thermistor X. By considering energy, explain why the potential difference across the terminal of the battery is less than the EMF. Because some of the potential is lost across the internal resistance. So you have to write sum of the potential, sum of the voltage is lost across internal resistance of the cell. That's why it's smaller than. The charge of the 2.5 kilocoulomb passes through the battery. Calculate the total energy transferred. So energy formula is equal to charge multiplied by voltage. So 2.5 into 10 power 3 for the kilo and multiply by the total voltage supplied is 6. So 2.5 10 power 3 multiplied by 6, you will get answer 1.5 into 10 power 4 joule. Next is the number of electrons that pass through the battery. For the number of electrons, look, this is the total charge, 2.5 10 power 3. This is a total charge. And 1 electron charge is 1.6 into 10 power minus 19. So the total charge divided by charge of the electron. So when it's divided, the answer is coming 1.6 into 10 power 22. So these electrons are moving to the wire. The combination resistance of the external resistor and the thermistor X connected in parallel is 4.8. Calculate the resistance X. Look at the diagram. Both resistors, external and thermistor, are connected in parallel. So we can write 1 over R, 1 over R1, 1 over R2. And the combined resistance, total resistance is 4.8. Is 1 over R1 required. And the other resistance is 12. So 1 divided by 12. So we can write 1 divided by 4.8 minus 1 by 12 is equal to 1 over R1. Now, after calculation, so take the LCM and then multiply or use calculator direct. 1 over 1 4.8 minus 1 over 12, and then the reciprocal of this. The answer is coming approximately 8 ohm, so 8.6. The next, use the answer in B3 to determine the power dissipated in X and the power dissipated in 12 ohm resistor. So the power is V square over R. So V square over R, V square over R. So voltage is same. So we can write then this is 1 over 8. This is 1 divided by 12. So it will be 12 divided by 8 and the 12 divided by 8 because voltage is same, resistors are different. X resistance is 8 we have calculated and this is 12. So 1 over 8, it becomes 12 over 8 and the answer is 1.5. And the next part is the temperature of the thermistor X is now decreased. State and explain that. Okay, so the thermistor temperature is reduced now. State and explain the effect, if any, of the temperature change on the total power produced by the battery. Look, as the temperature of the thermistor decreases, resistance of the thermistor increases. This is the first point, first mark. So temperature decreases mean resistance of X increases. One mark right. So the total resistance also increases. Total resistance of circuit also increases. When resistance increases, current in the circuit decreases, and due to decrease in the current, power also decreases. So 1 mark, 2 mark, and 3 mark. So 3 mark. Now move to the question number 7. Very simple question. A nucleus X decays by emitting a beta positive, mean positron particle to form a new nucleus, sodium 1123. State the number of protons and the number of neutrons in the nucleus X. Look, X is decaying and it is converting into the sodium. So definitely positron emitted, and the positron is emitted when proton is converted into neutron. So it means the X is carrying more protons, mean the 12 protons. So one of the proton of the X is converted into neutron. That's why the positron is emitted. Positive electron is emitted. So the answer for the number of protons is 12. Now the next, the number of the neutrons. You have to calculate the number of neutrons. Look here, 23 minus 11, it is 12. 23 minus 11, these are the number of the neutrons. So definitely, when one proton converted into neutron, so this has the addition of 1, so it is carrying 11 neutrons because its proton number decreases and the neutron number increases. So this nucleus, which is X, is carrying 11 neutrons. State one similarity between a positron and beta particle, mean electron. So they have same mass. Same charge, but opposite in polarity. State the quark composition of meson. So it has one quark and one antiquark. So the particle which is containing only quark, that is proton neutron, but due to the anti-quark, it is meson. Next question is, a hadron consists of the two quarks and one charm quark. Determine the charge of the hadron. Show your working. So it has two quarks and one charm. So one down quark, two down quarks, and the down quark charge is -1/3 elementary, and the charm quark charge is +2/3 elementary. So down plus charm is the charge. So -1/3 and +2/3. So it becomes -2/3 plus 2/3. The answer is 0. It has no charge. So this is the paper.